This is Chapter R Review, page 3. We're asked to simplify a couple of expressions. Though in the previous examples we were multiplying expressions, now we are adding and subtracting. So, right here, we've got to subtract two expressions. In this case, here's where we need to find that common denominator. I look at this and I realize these are not the same. So, let's break them down into their parts. X squared minus 25, well that's the difference of squares, x plus 5 times x minus 5. X squared minus 3x minus 10, well that's x minus 5 times x plus 2. Now, I've got them broken down into their factors. I can see that they have the minus 5's in common. But on the left-hand side, I need an x plus 2. And on the right-hand side, I need a x plus 5. So, I'm going to multiply the left-hand side by x plus 2 over x plus 2. On the right-hand side, it's x plus 5 over x plus 5. And I've still got x plus 8 over x squared. Oh, no, x plus 5, x minus 5. I'll leave it in factored form because those are easier to deal with. Now on the right-hand side, I've got 3 over x minus 5 times x plus 2. And now I've got that common denominator, x plus 2, x plus 5, x minus 5, x plus 2, x plus 5, x minus 5. With that, I can combine my terms. I've got on the top x plus 2 times x plus 8. And now these are subtracted, minus 3 times x plus 5 all over x plus 2, x plus 5, x minus 5. Now what some people sometimes want to do is cancel out these terms, the x plus 5 or the x plus 5. You cannot do that because of these subtraction. What we've got to do is combine our terms on the top first. So let's multiply x plus 2 times x plus 8. That's x squared plus 10x. Is that plus 10x? Yes. Plus 16. Now minus 3 times x is minus 3x. And minus 3 times 5 is minus 15. All of that is over still x plus 2, x plus 5, x minus 5. Now combining the terms on the top, I've got an x squared. 10x minus 3x is going to be plus 7x. 16 minus 15 is going to be plus 1. All that's over x plus 2, x plus 5, x minus 5. That is as simple as I can make it. I'd like to be able to factor to the top some more and maybe cancel some stuff, but I cannot do that. So I'd say that this is done. The second problem. X plus 8 over x squared over 1 plus 2 over x. This problem by no means looks simple because I've got fractions in fractions. But hopefully I can deal with those on their own. So let's start with the top. This top fraction, well, I'm going to find a common denominator in there. The denominator should be maybe x squared, so I will multiply by x squared over x squared. That gives me x cubed on the top over x squared plus 8 over x squared. Let's take a look at the bottom half. What's my common denominator going to be there? Well, I think I'm going to have to multiply by x over x. This gives me x over x plus 2 over x. Now, still focusing on these two separate fractions, in the top I've got a x squared in the denominator on both of those, so I can combine those to be x cubed plus 8. All of that's over x squared. In the denominator of my major huge fraction, I've got x plus 2 all over x. Now that I've combined my terms, I now have some standard fractions over fractions, no longer putting them together piece by piece. I can divide my fractions. The way that we do that is by flipping and multiplying. X cubed plus 8 all over x squared. Now it's times, and if I flip these bottom fraction, x over x plus 2. Now right away I can see a couple things cancel. This x cancels off with the squared. By the way, anytime you're multiplying fractions, we're just multiplying across the top and multiplying across the bottom. No more finding a common denominator. You can just multiply. The one more thing that we have to look at comes in this x cubed plus 8. That right there is the sum of cubes. X cubed is a cube and 8 is 2 cubed. So this will be x plus 2 times x squared plus 2x plus 4. And make sure you get the signs right. That is minus 2x, not plus 2x. It's important, definitely, to remember your sum and difference of cubes. And all of that's going to be divided by, well, in the denominator I still have an x, and I still have a x plus 2. Now I can see again, more stuff is going to cancel. This x plus 2 cancels with the x plus 2. I am left with x squared minus 2x plus 4 all over x. That is as far as we can go. We can't cancel anything else, so I would say that we are done. I hope you found page 3 helpful, and page 4 is coming up soon.